Hello to all of you. This is Dr. Dhaval Maheta, and let's discuss today the factor analysis. Factor analysis and principal component analysis is a statistical technique to reduce a large number of variables into the fewer number of factors. These techniques are used in the analysis of validation of constructs, creating measurement index, scale construction, and data reduction. Now let us try to understand factor analysis by this pictorial representation. On your screen, you can see different means of transportation. Now let us club all commercial vehicles together, all private vehicles together, and bicycles together. If I denote x-axis as a private transport and commercial vehicle and y-axis as two-wheeler and four-wheeler, I can segregate the entire all the means of communication can be segregated into only four quadrants. Two-wheeler, private transport, bicycle will be there. Private transport with four-wheeler, the private vehicles will be there. Commercial vehicles with four-wheeler, the commercial vehicles will be there. So basically, we can say that the factor analysis is a dimension reduction technique. Factor analysis is used to identify one or more common domains for the group of correlated variables. Factor analysis is a technique used to identify the pattern of correlations between the observed measures. For examples, indicators of job satisfaction, political attitudes, self-esteem, socioeconomic status, health, or family values. There are some assumptions of the factor analysis which we'll have to follow. The first assumption, as far as the measurement level of the variables are concerned, interval or ratio variables from the input for a classical factor analysis is necessary. With regard to the number of observations necessary for the performance of factor analysis, one may say that for every variable there are at least 10 times as many observations necessary. For example, for one statement, you require minimum 10 observations. So if you are having 5 statements, minimum 50 observations are necessary. Now, there are some more methods to calculate the sample size, or you can say many more rules are there. I have listed down the rules according to the popularity in which they are used. First rule is 10 cases per item in the instrument. Means one question, 10 cases. Subjects to variable ratio, this number should not be less than 5. Subjects means the total respondents divided by the total statements. This ratio should not be less than 5. 5 times the number of variables or 100. 5 times the number of variables or 100. The fourth one is minimum of 200 cases regardless of STV ratio. STV is subject to variable ratio. We'll be using Kaiser-Meyer-Olkin measure of sample adequacy. It's a test conducted to examine the strength of the partial correlation between the variables. KMO value closer to 1 are considered ideal, while values less than 0.5 are unacceptable. Recently, most scholars argue that the KM of at least 0.80 are good enough for factor analysis to commence. So here you can see the chart. When we'll run the factor analysis, it will generate the KMO statistics, which is a measure of sample adequacy. So if you get KMO more than 0.9, it is marvelous. Between 0.80 and 0.90, it is meritorious. Between 0.70 and 0.80, average. 0.60 and 0.70, mediocre. 0.5 to 0.60, terrible. Less than 0.5, it is unacceptable. Please don't carry out the factor analysis. Then there will be one test which is known as a Bartlett test of sphericity. The Bartlett test of sphericity is used to test the null hypothesis that the correlation matrix is an identity matrix. An identity correlation matrix means your variables are unrelated and not ideal for factor analysis. It is necessary that in this case, the p-value is less than 0.05 so that we reject null hypothesis. The null hypothesis here is the correlation matrix is an identity matrix. It is necessary to reject it. The data source, you can see here the links are given here. You can also see the links in the comments box. You can download the data directly from here. Now, I'll go in SPSS and you can see the data file. We are having 23 statements which have been captured on Likert scale. Let us see all the statements one by one. Statistics makes me cry. And the responses have been taken on 5-point Likert scale, where 1 is strongly agree, 2 is agree, 3 is neither, 4 is disagree, 5 is strongly disagree, 9 not answered. My friends will think I am stupid for not being able to cope up with SPSS. Standard deviations excite me. I dream that the Pearson is attacking me with the correlation coefficients. I don't understand statistics. I have a little experience of computers. All computers hate me. I have never been good at mathematics. My friends are better at statistics than me. Computers are useful only for playing games. I did badly at mathematics at school. People try to tell you that SPSS makes statistics easier to understand. I worry that I will cause irreparable damage because of my incompetences. Computers have minds of their own and deliberately go wrong. Computers are out to get me. I weep openly at the mention of central tendency. I slip into coma whenever I see an equation. SPSS always crashes when I try to use it. Everybody looks at me when I use SPSS. I cannot sleep for thoughts of eigenvectors. I wake up under my duvet thinking that I am trapped under the normal distribution. So these are all, you can say, are common problems related to the statistics and computers and all that. My friends are better at SPSS than I am. If I am good at statistics, my friends will think I am not. Now, these are all the statements. Now, our objective is to make groups out of these 23 statements, or rather, in a simple language, can I club these 23 statements into 4 groups or 3 groups? And then I will name these groups. So let us see, is there any, you can say, is there any way in which I can club them together or not? So I'll go in analyze, I'll go in dimension reduction technique, and I'll activate factor. Now make sure that you only transfer the statements here. No demographic variable is to be transferred. Gender or occupation will not be transferred. Only statements which are asked on Likert scale are to be transferred. Activate the descriptives. Make sure univariate descriptives is on and KMO Bartlett test of sphericity is on. Continue. Extraction. Click on screeplot and fixed number of factors. 4 factors are to be extracted. 4 factors. Continue. Click on rotation. Activate the varimax rotation. Continue. Click on scores and save as variable and activate the Anderson-Rubin. Here we don't have the factor scores at present. You can see here after 25 there is nothing. But once when I'll run the factor analysis, 4 new variables will be generated, which we'll discuss later on. But save as variable, the method is Anderson-Rubin. Continue. Click on options, sorted by size, suppress small coefficients. So any coefficient whose absolute value is less than 0.5 will not be included. Continue. Click OK. And you have got the results. So you can see this is the first descriptive statistics table which is there. Now how to interpret this? Let's see. So this is the same table which was there in the SPSS output. Anything which is written in red, you will not write in your thesis or your paper or your dissertation. I've written here just for the sake of explanation. If any statement has a mean, you can see here, this is a mean, less than 0.5 or greater than 4.5, and standard deviation is nearer to 0, it means that the respondents have done the extreme tick, either on strongly agree or strongly disagree. And as there is no variation in this statement is not at all useful. You can see here the mean is not less than 0.5 or greater than 0.5, and the standard deviation is also not near to 0, and therefore this is a good sign. What the thing is, let us understand what the problem can arise. If any person has done all the extreme ticks, or rather you can say that 5, 5, 5. This way the ticks have been done. In such scenario, the statement 1 will have a mean above 4.5, or there can be extreme ticks like 1, 1, 1, and in that scenario, your mean will be less than 0.5. Both are not advisable to run the factor analysis. You will not get the good result of factor analysis. Let us proceed further. So this is a reason we should generate the descriptive statistics first. Next is, you will have to see the KMO and Bartlett test. I have simply copied the output from here, this output. The KMO, I have copied it here in the Word file. Okay. My null hypothesis is correlation matrix is an identity matrix. Alternative is correlation matrix is not an identity matrix. This is desirable. You see the p-value of Bartlett test of sphericity and you see the KMO value. So our interpretation is, as the p-value of the Bartlett test of sphericity, this one, is less than 5% level of significance, we reject null hypothesis, which means that the correlation matrix is not an identity matrix. Quite good. Kaiser-Meyer-Olkin measure of sample adequacy should be greater than 0.7. This value should be greater than 0.7, indicating sufficient items are there for each factor. Here, the results of KMO is 0.930, which is greater than 0.7, and therefore you can say there are the sample size is adequate. Next thing is communalities. Communalities. I have simply copied this in my Word file and let us see what to interpret. You will not write anything which is written in red in your thesis or your paper. For a good statement, communalities should be greater than 0.5. But in this case, statistics make me cry and my friends will think I'm stupid. They are having communalities less than 0.5, which is not desirable. Okay, let's proceed further. The next table which is generated is total variance explained. This I will get it from here. This one. When we run factor analysis, it will extract the eigenvalues for 23 statements, 1 to 23. On that basis, it will calculate the percentage of the variance and the cumulative percentage variance. Initially, when we are running the factor analysis, it will start the algorithm in such a way that each and every component will be having an eigenvalue 1, 1, 1, 1 that way. Then the first component is now having the eigenvalue 7.2, which is more than 1. Second is 1.739. Third is 1.317. And fourth one is 1.227. So these four factors, these four components are having an eigenvalue more than 1. And that is a threshold limit which was specified. Now when you do total of this, it will be exactly 23. If the total is done of this column, it will be 23. So 7.290 divided by 23 will give you this figure 31.696. 1.739 divided by 23 will give you the figure 7.56. 1.317 divided by 23 will give you the figure 5.725. 1.227 divided by 23 will give you 5.336. Now we will see the cumulative percentage. 31 plus 39 plus 44 will give you, 31 plus 7. 31.7 will give me 39. 39 plus 5 will give me 44. 44 plus 5 will give me 50. 50 plus 4 will give me 54. Now I have to do the interpretation. Let us see. The total variance explained table shows how the variance is divided among 23 possible factors. Note that 4 factors have eigenvalues greater than 0.1. I am talking about this row, which is a common criterion for a factor to be useful. When the eigenvalue is less than 1, this means that the factor explains less information than the single item would have explained. It can be concluded here that these four factors extracted from all these variables are explaining about 50.31 percentage of total variance. This figure 50.31. Ideally, it should not be less than zero point 0.6. Ideally, it should not be less than zero point 0.6. It should be more than this. Let's proceed further. Next we get is a Scree plot. So this also I have copied from here only. Scree plot. This Scree plot should have a elbow shaped curve. Elbow shaped. You can see it's an elbow shaped curve. Moreover, on x-axis we are having component number, and on y-axis we are having an eigenvalue. If you draw a line of 1, you can see here 1. We are in the position to, we can say that how many factor solution is an appropriate, or rather it is a correct solution. So if I draw a line at 4, 1, 2, 3 and 4. So the 4 factor solution is the best for this data. So we have used 4 factors only. Okay. Then the interpretation is to be done according to the rotated factor matrix table. SPSS will generate 2 outputs. One, the component matrix. Please don't use this table for interpretation. The best interpretation you will get it from the rotation which we are given, that is a varimax rotation. So rotated component matrix. I have simply copied this result in the Word file. So first I have copied this first part, then this second part, this one, then the third part which has been extracted, third part and fourth part. Or in other words, you can say this is first factor, second factor, third factor, fourth factor, which means that in first factor all the statements are clubbed together. In second factor all the statements are clubbed together. In third statements, the remaining statements, third and fourth remaining statements have been clubbed. Now what interpretation we will get from here? Let us see. The factor analysis has identified 4 factors. Read these statements. I have a little experience of computers. SPSS always crashes when I try to use it. I worry that I will cause irreparable damage because of my incompetencies with computers. All computers hate me. Computers have minds of their own and deliberately go wrong whenever I use them. Computers are useful only for playing games. Now, if you see these statements, and if I want to give a common name to this statements, I can give the fear of computers. One thing you should remember, that giving a name is a prerogative of the researcher. It is a stand what name he or she wants to give. So depending upon the statements, a common name which can be given to all the statements is a fear of computers. Let's proceed further. And let's see the other statements. So again, what I have done is I have copied this part. I cannot slip for thoughts from there. How many statements are there? Let us pick up 1, 2, 3, 4, 5, 6. In case if you get negative value, you will have to reverse the scale of this statement. Okay. Now let us see these statements. Fear of statistics. What are the statements which are there in this? I cannot sleep for thoughts of eigenvectors. I wake up under my duvet thinking that I am trapped under the normal distribution. Standard deviations excite me. People try to tell you that SPSS makes statistics easier to understand, but it does not. I dream that Pearson is attacking me with the correlation coefficient. I weep openly at the mention of central tendency. So if you see these statements, it is all, you can say, a common name which can be given is a fear of statistics. Now let us proceed further. Let's see the another third factor. I've been never good at mathematics. I slip into coma whenever I see an equation. I did badly at mathematics at school. So this is all fear of mathematics. A common name is fear of mathematics. Then comes the last part. My friends are better at statistics than me. My friends are better at SPSS than I am. If I'm good at statistics, my friends will think I am a nerd. My friends will think I'm stupid for not being able to cope up with SPSS. So you can say the name which can be given is peer pressure. So the factors which have been generated, let's give the name in our data file. So I'll go in variable view. You can see that 4 new variables have been generated. Factor 1, factor 2, factor 3, factor 4. So what was the first factor? It was fear of computer. What was the next factor? It was a fear of statistics. Then fear of mathematics. Peer pressure. Now, next, what we can do? Now I want to see that this fear of computer which is there, is it equal in male and female? Fear of statistics according to the gender, fear of mathematics according to the gender, peer pressure according to the gender. One. The second thing which I can see is according to the occupation. Now this thing is not there in your original data. I have inserted this extra 2 variables to make you explain what you can do with your factor scores. So gender and occupation, these are the variables which have been entered by me to make you explain that what we can do with the factor scores. Okay. Now what I can do is I'll go in analyze, compare means, and I'll run independent sample t-test where I'll transfer factor 1, factor 2, factor 3, factor 4 into the test variable. And in gender, I'll include gender into the grouping variable. Define groups. 2 groups are there. 1 male, 2 female. Continue. Click OK. And you've got the result. I have simply copied this result in the Word file. This result in the Word file to make you explain. First, you should always see the equal variances assumed table. If variances are equal, then you should see the first line. You should interpret this from the first line. If the variances are not equal, you should interpret from the second line. You can refer my video number 29 of this lecture series to understand how to do the interpretation of independent sample t-test. Okay, I will copy this result in my Word file and let us see what further analysis which we can do. Again, we can frame one hypothesis. Research hypothesis is males are having more fear of computers in comparison to the females. I'll convert this into the statistical hypothesis. There is no significant difference in fear of computers according to the gender. Or you can write the same null. Fear of computers is in male and female is equal. Alternative, fear of computers in male and female are not equal. We have got the result independent sample t-test. Let me expand this. You can see that the SIG value of all of them is more than 0.05, right? And here it has also given the group statistics. This is a group statistics, which I got it from here, this one. Okay, let's proceed further. How to interpret? There can be 2 possibilities. Okay, before writing the interpretation, let us understand this concept. 1 is coded as strongly agree, 2 is coded as agree, 3 is neutral, 4 is disagree, and 5 is strongly disagree. You can see this thing from your coding window. Go in variable and see the codes which have been given. 1 strongly agree, 2 agree, 3 neither, 4 disagree, 5 strongly disagree. Okay. So when we run this factor analysis, this scores will be standardized. So now I will get the result according to the standardized score. So -2, -1, neutral is 0, 1 is 4, and this is 2. Now, in case if p value was significant, means if I'm talking about this value. I'm talking about this value. Let me insert a shape from here. And if this was significant, if this value was less than 0.05, this means that the fear of computer is not equal in male and female. So how will I write this? In case if p-value was less than 0.05, so we reject null hypothesis, which means that fear of computer is not equal in male and female. Now we'll have to see the mean of female of fear of computers and mean of male of fear of computers. So that figure I will get it from here. From your descriptive statistics, you pick up this figure. This one. Male fear of computers is 0.122, female minus 0.012. Similarly, fear of statistics, male, female, fear of mathematics, 0.021, and here minus 0.021. In peer pressure, it is negative. See, male is 0.038 and female is 0.038. Okay. So this interpretation is to be done only when you get p-value less than 0.0. Now see, the mean of female is minus 0.02. So where it will be? So you can see here, the female will be here. Mean is minus 0.012 and of male is positive. So it is 0.0122. Now in case of, so if I write here as fear of computers, this is the scenario. Now let us see for fear of statistics. It is positive and negative. The mean is positive and negative. So it will be again the same thing. Fear of statistics. Again, let us see for mathematics. It is positive and negative. So again, it will be male and female. Male is on the positive side, this one. So fear of mathematics. Let me insert one more column. And the last one, peer pressure. Here, male is negative, mean value, and female is positive. This means that I will write down male on this side. Okay, I'll have to change this also because it was female was positive. So I'll change this female in the previous case. Okay, this is male. And in case of peer pressure, this is male and female. And here it is peer pressure. Now, how to interpret? See, females agree on the factor fear of computers more in comparison to male. Females agree more on fear of statistics in comparison to male. Fear of mathematics, females agree more in comparison to male. Peer pressure, it is reverse. Males agree more in comparison to females. Now, how will I write this? I again repeat, the interpretation is to be done only when your p-value is significant or rather t-test is significant. So the mean of female is 0.012 and mean of male is 0.0122 for the factor fear of computers. This means that females have agree more on fear of computers in comparison to male. Now the second part, it can also happen, which is a real case, this part. Actually what we have got, the previous case was just an assumption that the p-value is less than 0.05, but here our p-value is more than 0.05. Now what? So our interpretation will be As the p-value of t-test is 0.533, which is more than 5% level of significance, we fail to reject null hypothesis, which means that the fear of computer is not affected by the gender, or in other words, fear of computer is equal in male and female. Okay. Now, what else? We can use this scores further, and we can also run according to the occupation. In occupation, we have got more than two categories: salaried, self-employed, and professionals. Let us see. Analyze, compare means, one-way ANOVA, and I'll transfer only one factor. You can transfer all the four factors also, but I'll transfer only one first factor, and that is a fear of computers. Occupation. Click on post hoc, tick on Tucky's test, continue, click on options, make sure you click on homogeneity of variance test, descriptives, continue, click OK, and you got the result. The first thing which you should see is the test of homogeneity of the variance. It is vital, or it is essential, that your p-value should be more than 0.05, which means that the variances of all these three groups are equal. If the variances are equal, then only the interpretation will be done of ANOVA. I'll request all my viewers to refer video number 32 of one-way ANOVA to understand that if the variances are not equal, in that scenario, what to do. So in that scenario, we are running Welch test. So as the variances are equal, we got ANOVA, and the post hoc test is Tucky's test. How to interpret? Let's see. Our research hypothesis will be, first of all, test of homogeneity of variance. Our research hypothesis will be, salaried respondents have more fear of computers in comparison to professionals. We will convert this research hypothesis into a statistical hypothesis, which means that there is no significant difference in the fear of computers according to the occupation. Alternatively, there is a significant difference in fear of computers according to the one pair of occupation. I'll request all my viewers to refer video number 32, in which I have discussed one-way ANOVA. The first thing which you should see is a test of homogeneity of variance. As the p-value of this test is more than 0.05, variances are equal, we got the value of ANOVA, which is 0.624. SIG value is 0.624. And on that basis, multiple comparisons have been done. Now, in case if p-value is less than 0.05 of ANOVA, at present, what we have got is this value is more than 0.05. But hypothetically, or rather have an assumption so that you can understand how to write the interpretation. If this value was less than 0.05, how would I have interpreted? So, in case if p-value was less than 0.05, so we reject null hypothesis, which means that fear of computer is different in at least one pair of occupation. At least one pair of occupation means salary compared with self-employed, self-employed compared with professional, or salaried compared with professionals. Now, we will have to interpret this thing from the post hoc test, which is a Tucky's test. So again, I will have to go in the Tucky's test and see that is the p-value significant there also. So here, all p-values are more than 0.05. But let us assume this scenario. Let us assume this is just an our assumption 0.00000000. 0, 0. Now this means that the difference between the salaried and self-employed is significant. Then only I will have to write the post hoc interpretation. If this p-value was more than 0.05, I would have not written the interpretation. So I'm giving you just an example. Okay. Then I will have to see the descriptive statistics, that is fear of computers. This I will get it from here, from the descriptives which is being generated initially. This one. Now, salaried is having a negative value, self-employed is positive, professionals are positive. So, same way which we did in gender, salaried is negative, self-employed and professionals are positive. Now, how will I write the interpretation? In case, if it was significant, so we reject null hypothesis that we have done. Okay, this one. The mean of salaried is minus 0.023. Mean of self-employed is 0.0025 and mean of professional is 0.0227. I'm talking about this part, which I got from descriptive statistics. This part. For the factor fear of computers. This means that respondents who are salaried agree more on fear of computers in comparison to professionals. How come this interpretation we have arrived? See, salaried, it is negative and therefore it is on towards the agreement side. Now the next part. In case if it was not significant, our ANOVA was not significant, which is our real story. Here it is 0.624, right? Let me change this to 0.624. This one. What would be my interpretation? So in this case, we will not go for post hoc because we failed to reject null hypothesis. As a p-value of let me change this to ANOVA. As the p-value of ANOVA is 0.533, which is more than 5% level of significance, we fail to reject the null hypothesis, which means that the fear of computer is not affected by the occupation, or in other words, fear of computer is equal in salaried, self-employed and professional respondents. Here you can write this thing as the p-value of ANOVA is less than So this is the way you can run factor analysis in SPSS and also use the factor scores for further analysis. For more videos on SPSS, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please don't forget to press the like button and subscribe the channel.